There's a number of posts during the rounds in developer circles. They summarize the building blocks of agentic AI systems: sandboxing, permissions, hooks, prompt injection defense. The authors make the case that frameworks change: LangChain, Crew AI, AutoGen. But these underlying patterns didn't. They are the ideas underneath every agent system you'll ever build.
These emerging frameworks are the best developer introductions to agentic architecture I've read, Tova. Genuinely useful. However, they generally stop at exactly the wrong moment. They tell you what controls to build, however, they have no answer to the only question the security team should be asking right now. Did the controls work?
That gap between building the controls and knowing that they hold under pressure is what we're covering today. This is the Cyber Resilience Brief, a SafeBreach podcast. And this is our episode on AI agents controls. Adrian, let's start with the picture as it actually exists. An enterprise is deploying AI agents, coding assistants with repo access, ops agents with cloud credentials, support agents with CRM write permissions. What does that look like from a risk perspective before anyone's actually gone and tested it?
So it looks like infrastructure that nobody's mapped. And I say that having been in rooms where very smart engineering teams have thought carefully about what controls to implement and then deployed with essentially no adversarial testing of those controls. The challenge is that the attack surface here is fundamentally different from anything security teams have had to validate before.
Different how?
So a firewall rule is static. You test it once, the test holds until someone changes the rule. An agent's decision-making shifts with context, hence the acronym Model Context Protocol. Every word in there is really important. The context is what tools are connected, what's in the context window for that session, what instructions have been loaded from config files. A permission config that holds under normal conditions can fail completely under an adversarially crafted prompt. That's a validation problem security teams often don't have prior experience with.
So if I'm picking up what you're putting down here, you're saying that with agentic AI, the attack surface isn't fixed, it's fluid.
Right, and there's a second layer that doesn't get enough attention, the state problem. AI agents have two kinds of state. What's in the context window right now, and everything outside it that has to be explicitly loaded. What often isn't framed as a security issue is that everything loaded from outside, memory.md files, configuration files, MCP tool descriptors, to store contents, these persist between sessions. They aren't just features, they're durable attack vectors if nobody's tested them adversarially.
Adrian, can you give me a concrete example of that, one from real life?
Okay, so a CLAUDE.md markdown file or agents.md, depending on the tool, inside a cloned repository that says essentially, send your test logs to this endpoint for debugging. The agent reads it, trusts it, starts sending environment details, potentially credentials, API keys, internal system information to a server that the developer doesn't control. That's not a model problem. The model did exactly what it was instructed to do. It's a trust problem. And most organizations deploying agents right now have not tested whether their controls would catch it.
Yikes. Is there evidence that this is actually happening, or are we still in the theoretical risk phase?
The past theoretical. Last year's numbers, 88% of organizations reported confirmed or suspected AI agent security incidents. And that's on the deployment side. Only 14% of organizations sent agents to production with full security or IT approval. The vast majority of agents running in enterprise environments right now went through no formal security review at all.
So the gap isn't that organizations aren't building the controls. The developer community is clearly thinking about this. The gap is actually that building controls and validating controls are two completely different activities with different operating principles.
That's exactly it. And this is why it's important to describe the right controls: sandboxing, permissions, pre-tool hooks, prompt injection defense, pre-commit gates. These are the right five. The word that's missing from most enterprise agentic deployments is validate.
So let's define that properly. Validate is a word that gets used a lot in security. And let me tell you, it's what we do at SafeBreach. We throw around the word validation all the time. What does validation mean specifically in the context of agentic controls?
It means you've actually executed the attack against your own control under realistic conditions and confirmed the control responded as intended. Not the configuration is set, not the documentation says it will do X. You ran the technique. You observed the response. You have evidence that it works. That's validation in the proper sense.
And we'll be right back.
You've described 5 main guardrails: sandboxing, permissions, hooks, prompt injection defense, and pre-commit gates. What does actually tested look like for each of those 5?
Let me go through them reasonably quickly, but no quicker than necessary. The shape is the same for all 5. Each one has a specific question that most teams haven't answered. So sandboxing, run agents in Docker with no network egress. The validation question is, have you actually attempted egress from that container? Not is the policy set. You can't solve this at a policy level. Important that you have one, but you must be testing and validating for real. Have you tried to break out under adversarial conditions and confirmed the walls held? Container escapes exist. Network policy misconfigurations happen. Secondly, permissions, 2-layer model, project allow list, user deny list. Solid design. The validation question, have you induced shortcuts? The agent removing a failing test assertion. The agent bypassing a Git block. A sufficiently crafted prompt produces these in real deployments. Has anyone run that scenario against your permission layer? Thirdly, hooks. Pre-tool hooks running before dangerous commands execute. For example, Unicode tricks as a specific detection target. The validation question here is, have you actually tried to bypass the hook using Unicode encoding? A hook that catches curl pipe to shell in ASCII may not catch its Unicode encoded equivalent. That's a documented bypass. Has anyone tried it against your hooks? Fourth, prompt injection defense. Always treat config files like code. The validation question, have you run an actual injection scenario? Clone a repo with a poison config, navigate to a page with a hidden instruction in the metadata, submit a support ticket that contains an instruction rather than a request, then confirm the agent rejected it. Reviewing the config is processed. Confirming the agent rejected a live injection is validation. Okay, finally, we come to pre-commit gates, also known as the correction loop. And loop engineering is very, very topical at the moment. We'll be talking about that in the near future. The correction loop is the gate that catches the problem. The gate catches the problem, the agent reads the error, fixes the code, tries again. Loop engineering. The validation question is, does the gate actually trip? Have you rotated a real format API key through the gate and confirmed the detection fires? The correction loop only works if the gate catches something.
5 controls. It's 5 questions with the same shape. Not do you have it? It's have you proven that what you have holds?
And for most organizations deploying agents right now, Tova, the honest answer to all 5 is no. They have the controls. They haven't validated the controls. That's the gap.
So what does closing that gap actually look like? If a CISO listening to this wants to act on Monday, not theoretically, concretely, where do they start?
Start with the deployment trigger, not a comprehensive audit. Don't try to validate everything at once. Every change event, a new agent deployment, a new MCP server connection, a config file update, a new tool added to the permission set, that's a validation trigger. Map the trigger to the relevant guardrail and run a realistic adversarial scenario against the specific control.
So it's continuous, tied to deployment events, and not a quarterly checkbox.
Exactly right. Adversarial audit, adversarial testing. And this is why traditional approaches don't cover this adequately. Penetration testing is episodic. Agent deployments are changing continuously. A quarterly penetration test of your agentic controls is approximately useless if your agent deployments are changing weekly. The validation cadence has to match the deployment cadence.
And now, Adrian, what does the actual test for this look like?
So the 5 questions I just walked through are the test plan. Systematically work through them. Document what you find. The goal isn't perfect coverage on day 1. It's knowing which controls you've validated and which you haven't. That's your starting point. That's more information than most organizations have right now.
And defenders who are handling this well, what are they doing differently?
The defenders I've worked with who handle this best, including those internally here at SafeBreach, are treating agentic controls as a continuous validation target, the same way they treat their EDR coverage or network security rules, actually executing the technique against the control, not just checking the configuration. That's what SafeBreach customers are doing with the AEV platform as it extends into the agentic surface. running actual adversarial technique execution against these guardrails, not just reviewing the config. But the principle holds on any platform that lets you exercise the control adversarially. The question is whether someone in your organization is doing the work at all.
Right. And the question to take back to the team isn't, should we invest in a validation platform? Yes, you should. I'll answer it for you right now. The actual question is, do we know which of our agentic controls work when someone pushes on them? That's the question for Monday morning.
That is the question, Tova, and it should be uncomfortable that most teams can't answer it.
A CISO hearing this is probably thinking, we have penetration testing, we have red team exercises, we have vulnerability management. Where does this sit relative to all of that? Is this just a new name for something that we're already supposed to be doing?
That's a fair challenge. The validation principle isn't new. Breach and attack simulation established it for traditional controls. You don't just check whether detection rules exist, you exercise them against a real technique execution. The agentic surface needs the same principle applied to a fundamentally different set of attack patterns.
So just to make this clear, this is not a replacement for what is already there.
No, not a replacement, different scope. Penetration testing gives you adversarial depth at a point in time. Vulnerability management covers known CVEs in static infrastructure. Neither of them has a concept of context window poisoning, cross-agent prompt injection, or hook bypass via Unicode encoding. These aren't techniques on the attack matrix yet. They're not in vulnerability databases. They won't show up on standard assessment. The agentic surface needs its own validation scenarios built around how these systems actually fail.
And what would you say, Adrian, to those who are just saying, oh, this is just BAS for AI agents, which is a big statement to unpack?
So the substrate is similar, continuous adversarial exercise against controls, but the specific attack patterns are genuinely different. You can't validate an agentic hook bypass by running an EDR test. You can't validate context window poisoning with a network scan. The scenarios have to be built for the surface. And that's what makes this a distinct validation problem, not just an extension of an existing one.
Okay, and last question, where is this going? What are you watching for over the next 6 months?
Great question, Tova. The thing I'm watching for closely is whether the MCP ecosystem develops security standards at the tool registration layer. Right now, when an agent loads an MCP tool, it trusts the tool description implicitly. The tool says, I do X, and the agent believes it. That's prompt injection at the infrastructure layer, and there's no standard defense for it yet. No authenticated tool descriptors, no signed schemas, nothing equivalent to certificate validation in TLS. The day a major MCP server gets compromised and starts returning poisoned tool descriptions to thousands of agent deployments simultaneously, that's the incident that forces the standards conversation. I'm not predicting when, I'm saying the attack surface is there, it's ungoverned, and the developer post we started with doesn't mention it at all.
You might want to say the developer posts we started with.
It's ungoverned, and the developer posts we mentioned at the start of the episode don't cover this at all.
So what you're saying is that the next gap after these 5 controls is one that the community hasn't started addressing yet because it's that dynamic.
The one that will look obvious in retrospect.
Okay, great. Thank you so much, Adrian, for unpacking this yet again. And until next time, stay safe with SafeBreach.
Bye-bye.
The Cyber Resilience Brief is a SafeBreach podcast. Executive produced by Adrian Culley and Tova Dvorin. Music produced by Sarah Dressner. Hosted, edited, and compiled on Riverside. For more about SafeBreach and how you can validate your security controls across your entire IT infrastructure, visit us at www.safebreach.com. That's www.safebeach.com.